Hello, everyone. Today we will be covering Chapter 5, Part 1, and the first part of this lecture is about ethyl alcohol. This is basically drinking alcohol. And the second part is about inhalants, and it's just a very short lecture, so we'll just start off with alcohol first. The overview for this presentation is to learn about alcohol, so what is it? And also the way that alcohol is administered, distributed, metabolized, and excreted. We'll also learn about the pharmacokinetics of how alcohol affects the brain. And we'll learn about the blood alcohol concentration levels when a person drinks and even what is the legal and illegal limits. And we'll end with knowing more about alcohol tolerance, withdrawal, and also treatments for individuals who need to overcome alcohol abuse. So what is alcohol? The kind of alcohol that we drink is called ethyl alcohol, and it's also referred to ethanol. It's considered a psychoactive drug because it alters the consciousness, mood, and behavior when consumed. It's primarily used for recreational purposes, meaning that it's like used for fun versus for a medical purpose. Although it has been, I don't know if this has been prescribed by a doctor. It may have been, but it has been said that if you have like a glass of wine a day, it can lower your blood pressure and help your heart. But that's debatable, and so that's not necessarily prescribed as medicine. And I have a little bit of information about it at the end of this lecture. But anyway, let's move on. And alcohol is also metabolized differently than the way that most drugs are metabolized. Since it's a molecule that is mostly nonpolar, so if you see on this side of the chain, well, first of all, this is the alcohol molecule. And it's a small molecule with two carbons, hydrogens around it, and an oxygen. It's mostly nonpolar, okay? And if it's mostly nonpolar, do you think that it can easily diffuse into your cells? So can it easily enter your cells given that the molecule is mostly nonpolar? What do you think? If you said yes, that alcohol can easily diffuse through your cells, you are correct. And that's because our cell membranes are made up of fatties, like fatty molecules, fatty lipids, which are also nonpolar, and then nonpolar and nonpolar interact really easily. Therefore, when we drink it, our tissues easily consume it, like it easily absorbs to our tissues, and it's distributed through our body quickly. And our brain, it crosses the blood-brain barrier very easily as well. And so our brain absorbs it quickly. And so that's why you can feel the effect quite rapidly, even though you're ingesting it. And so the effects of alcohol can cause certain things. It just depends on the person and how much they consume. And so it can make a person emotionally unstable, easily excited or saddened. It can cause a person to lose coordination, have trouble making judgment calls, and remembering things. It can also cause blurry vision, a person to lose their balance and feel tired or drowsy. And in some cases, it also helps a person like relax. And if it helps them relax, then they can be more, I guess, outgoing. And this is why people drink in certain types of settings. Let's say, for example, like at a club, like if a person goes to a club, they drink so that they can not feel the anxiety of like being embarrassed of dancing in front of others, or maybe just having a good time or whatever, for whatever reason. I'm not judging. And so yeah, alcohol causes these different types of effects. Prohibition. So this was in the early 1900s. Prohibition was basically the illegal use of alcohol. So that means that alcohol was not allowed. It was not legal. And at the time, alcohol was purposefully turned into a toxic substance. And so what we drink is called ethanol alcohol. This is not toxic. But in the Prohibition days, it was purposely, this is just a side note, by the way, but it was purposefully turned into isopropyl, which is a different type of alcohol, methyl or wood alcohol, to prevent people from drinking. And so this is if it's not fermented well and if it's not purified well, this can happen. And as a result, a lot of people ended up dying from it. And that's because when this type of alcohol is metabolized, it can turn into formic acid, and that, which is basically formaldehyde, and that can cause nausea, vomiting, blindness, coma, and death. And so this is just a little side note about what used to happen in the Prohibition days and what types of alcohol are toxic to us. And so some people ferment their own alcohol as well. So they have to make sure that they distill it well and end up with the proper type of drinking alcohol, which is ethanol alcohol. And so there are three major types of drinking alcohol. One is beer, which contains 3 to 6% of alcohol total, and it can range. It can go higher, like some microbrews are from 8 to 9%. And the first recorded record of people, making and drinking alcohol was in Egypt, and so this is around 3700 BC. So BC means before Christ. And wine is another type of alcohol as well, and it is basically, or it contains about 12 to 20% alcohol, so it's a little bit more concentrated than beer. And it was first used, or at least its recorded use, was in Iran around 5400 BC. So, alcohol has been around for a very long time. And distilled spirits, which means basically the purification of these types of drinks to make them more concentrated. That's basically has been around since the Middle Ages. It's been recorded in the Middle Ages. And brandy was made out of distilling wine. And what I mean by distilling is basically getting rid of the other components and compounds, like water molecules, to purify and concentrate the alcohol. The way the alcohol is made is through fermentation. And so this is with yeast. And so all you do is feed yeast some type of sugar. To make wine, you feed them grapes and whatnot. And so sugar from grapes. And just depends, you can feed them different types of sugar. And so eventually what the yeast do is they kind of like, after eating sugar, they break it down and they give off a byproduct. It's almost like pooping. And so what they do basically is give off certain byproducts. So they'll give off oxygen, which is, removed. It's subtracted from the equation. And they also give off carbon dioxide and alcohol. So this is from the breakdown of sugar. This is after the yeast eat sugar. And then the alcohol is then isolated, after the yeast eat it. And in some cases, the carbon dioxide as well, which gives beer its like fizzy taste, like what makes you burp. So yeast die if they produce too much alcohol. They can only pretty much produce 10 to 15%. And so at this point, fermentation can only be used to produce beer or wine. And so the more concentrated types of alcohol are made through distillation. And distillation is basically a process of heating up the alcohol and precipitating it, and then collecting the precipitate, which then it's just basically concentrating the amount of alcohol that you're collecting. And then to make different types of alcohol, you could use, like, for example, in whiskey, grains, and rum, molasses are used. To make brandy, you distill wine. To make schnapps, you distill potatoes. And so this is just basically what is being fed to the yeast, and so on. And so tequila is made with blue agave. And I actually did a really cool tequila tour in Puerto Vallarta. I was there last week. It was a lot of fun. And so yeah, I did a tequila tour, which I was pretty surprised on the process on how it was made. And I was also like given like a little story about the good kind of tequila versus the bad kind of tequila. And then that guy that was giving this whole little tour was calling the bad kind of tequila to kill you because it tastes horrible, which I thought was funny. And he said that the good refined kind of tequila has a double distillation process, which basically removes the methanol. I guess the methanol tastes really horrible, and so it's methanol and ethanol mixed. And it just basically, the double distillation concentrates it to where you get pure alcohol and it's a little bit more smooth, and then it's aged and whatnot. So it's like aged in a barrel or something like that, which I thought was really cool. And so the very expensive tequilas that are like $80, $90 are the ones that are like double distilled, they've been aged and whatnot, which I thought was pretty interesting. But anyway, yeah, and so gin and vodka is made from pure alcohol, water, and flavoring. All right. So now let's talk about the statistics of alcohol abuse. Alcohol abuse, so this is if you're not just using it recreationally, because it's fine, if you have your drink here and there, if you have it like once a week and you can control, yourself, and it's not over consuming your life, then you're not basically in alcohol abuse. Like, you are just drinking in moderation. So there's drinking in moderation, and then there's over drinking. So alcohol abuse is basically also called alcoholism, and it includes binge drinking, and mostly drinking for prolonged periods of time to the point where it overtakes your life and you basically depend on it. And so for different people, it ranges. And so alcohol use disorder is a chronic disease characterized by alcohol dependence, uncontrolled drinking, and physical or emotional dependence on alcohol. And currently, well, this statistic here is like from 2017. I got this from your textbook, so I'm sure the numbers are much higher at this point. So in 2017, 16.6 million of 18 and over, so these are adults, and this is in America, were reported to have some type of alcohol use disorder. So that means that, they are chronically drinking. And a percentage of heavy drinking and binge drinking has been increasing. And so, I'm not judging in any way, why people drink, or, what the motives are. And, this lecture is not about that. But, some people drink to either, relax from certain situations. Maybe they have a stressful job, or maybe they want to overcome some type of traumatic stress that happened to them in their earlier years. Some people do it because they have PTSD, like veterans and whatnot. And so we don't really know the reasons why people do it. So, our job is not to judge anyone, but just to understand, what alcohol abuse means and basically what alcohol does to the body. So now let's talk about the ADME. So ADME means administration, distribution, metabolism, and excretion. So this is how alcohol enters our body, and this is like the pharmacokinetics of alcohol. And so the absorption of alcohol is rapidly absorbed from the stomach, small intestine, and colon, but the rate of absorption from the stomach is influenced by the food content. And so if you have eaten before drinking, then some of the food tends to absorb the alcohol, and so it may not enter your bloodstream. And remember, we talked about alcohol easily diffusing through your tissues because it's mostly nonpolar, and so that matches the membranes of your tissues, and so it can easily go inside. It can easily have an effect. Ethanol is evenly distributed throughout all fluids, so that means it's present in saliva and blood, in the cerebral spinal fluid, which is found in your brain, and also in your sweat. And so that's why some people who drink a lot, or if you've been drinking all day, you kind of can smell like alcohol because it's literally coming out of your pores. The distribution is based on total body water, and so women tend to have a lower proportion of total body water compared to men, even if they are the same weight. So since women have less total body water, that means that they can basically get drunk more easier. So women achieve higher blood alcohol levels compared to the man, even if they are the same weight and they drink the same amount of alcohol. And again, that's just because they have less water. So that means that there's more room for the alcohol to enter the bloodstream, and not, if it's not mixing with water very well, then it's more highly concentrated. If that even makes sense. Not that women don't have water in their bodies, they just have less than men. All right, so the metabolism. So the majority of the metabolism happens in the liver. So that's 85%, and then 5% is excreted unchanged from the lungs, meaning that you actually can just breathe out the molecules of alcohol. You can expel them without it being broken down whatsoever. And we also know that it can be excreted through sweat, and in small fractions. And so the liver can only oxidize about 10 to 15 mils of alcohol per hour. So that's why some people feel the effect of alcohol for several hours, because it just takes a while for the liver to detoxify it. And so until the liver gets around to oxidizing, and oxidizing means breaking down the molecule of all the alcohol consumed, that alcohol continues circulating throughout the body parts. So let's take a little closer look about the metabolism of alcohol and what it means. And so metabolism, once again, it's in the liver. And 90% of ethanol molecules are oxidized, meaning oxidized just means that the molecule is broken down. Specifically, it loses a hydrogen from the molecule. And if it loses a hydrogen, it just becomes another type of molecule. So it's just literally being broken down. And so most of the ethanol is oxidized by an enzyme called alcohol dehydrogenase, which is in short ADH. And so this is an enzyme that can break down a molecule. And so we go from alcohol to acetaldehyde after it is broken down from alcohol dehydrogenase. Once it is broken down to acetaldehyde, that can no longer make you drunk. So if this molecule is broken down and then you have acetaldehyde as a result, you no longer feel drunk. However, some people are good at breaking it down to acetaldehyde, but not very good at breaking down the next form into acetic acid. And so the next enzyme that breaks down the acetaldehyde is called acetaldehyde dehydrogenase. And so some people have like more of the first enzyme and less of the second enzyme. And if you have less of the second enzyme, which is interesting, basically you are in the group in which alcohol causes hangovers for you. And you're not likely to have any type of alcohol abuse because of how bad alcohol feels to your body, just because you're not able to break it down that well. And I actually think I'm in one of those groups because I get bad hangovers, I get really dehydrated, and so that really does prevent me from actually drinking more than I probably would. Like I'll just have a couple of drinks because I just get these like headaches and stuff. And so yeah, some people actually can't break down alcohol that well. And some people, well, it is believed through studies that some people who break down alcohol really well, and so that means that these two enzymes are very efficient into breaking down the molecule, meaning that you metabolize it very well. So if you metabolize it really well, the alcohol no longer has an effect on you. And if it doesn't have an effect on you, and if you don't have hangovers or nothing like that, that means that you can drink more. And that means that you're those type of people, this is according to some studies, those type of people are more likely to have some type of alcohol abuse because of how well their body can break it down. I mean, this is just according to some studies, but it's possible that some people are more genetically predispositioned to abuse alcohol and drugs just because of the way their body breaks it down. So, certain studies are starting to show that some people are just more prone to it. Now, I have a friend, and I guess I don't know what category she would fall into, but she couldn't get drunk. Like, she could drink 3 glasses of wine, she can drink 2 shots of tequila, and she would not get drunk. And I didn't believe her, this is when I first met her. I thought that was hilarious and I didn't believe her. I actually had her prove it to me, so I had her drink a couple of shots back to back, and nothing happened to her. It was like drinking water, which I thought was hilarious. And so I don't know if she has enzymes that are, like she has a ton of both enzymes that are very overactive that break down the alcohol right away, in which she just doesn't feel the effect. Like, I don't know what category she falls under, or if her body even breaks it down at all. But if her body didn't break it down, then she would probably feel really drunk. So I don't know. I'm thinking maybe she had very overactive enzymes. But anyway, so here, genetic polymorphisms, meaning that some people have different variety of ADH and ALDH. Oops. I put ACH here, so it's actually ALDH. This enzyme here is ALDH, so I have to fix that. So anyway, some people have different amounts that they produce, so that means that they just have a different tolerance level. And just one more side note, you know how there's some people that get kind of like red in the face. I had a friend, and of course, and this is not like a stereotype or anything, but Asians tend to have this problem, and so it's found in Japanese and Chinese people that they have like a poor acetaldehyde enzyme. So they have like an enzyme that doesn't work that well, and so they end up with a lot of acetaldehyde in the body, which basically is kind of toxic to the body, and it causes that redness, that flush. And so they can't tolerate alcohol that well either, so they won't drink that much. And I had a friend that happened to her, and she really hated drinking. Anyway, all right, so moving on from metabolism to excretion. So excretion is basically how the alcohol leaves your body. 5% of the alcohol is excreted through the kidneys. Actually, oh, I see, of pure alcohol, sorry. So 5% of pure ethanol is excreted through the kidneys, urine, sweat, and breath. And so this is when it's not broken down. But when it's broken down, then, obviously you pee it out. Although some of it is turned into water and energy if broken down efficiently. All right. Now let's talk about the pharmacokinetics of alcohol. Let's continue. So how does this affect the brain? And so what do you think? Do you think alcohol affects the reward pathway? And if your answer is yes, you're correct. So pretty much any type of drug that is addictive does definitely stimulate the reward pathway, which is all of the brain structures that are involved in having an individual feel pleasure. And, these structures are necessary for our survival, because if we didn't find pleasure, like in food and in sex, we wouldn't be procreating, we wouldn't be having more people, like more children, our species wouldn't continue. And if we weren't eating, then we wouldn't survive. And so, we had to find pleasure in things. So when a person first drinks alcohol, it feels like a stimulant. It feels like something that wakes you up, because it activates the reward pleasure pathway. And so this is one of the first things that happens, which in turn sends messages to the cortex to be coded as experiences and perhaps as memories, meaning that a person is going to remember that, oh, that was fun, that felt good, and they're going to want to do it again in some other future time. And since these memories of drinking are linked to the environment in which drinking took place, it is not surprising that the environment cues can be important in guiding subsequent drinking behavior. So meaning that if a person likes to drink at the club, then every time they go to the club, they'll most likely grab a drink. So let's talk about the neurotransmitters that are affected by alcohol. And remember, that's why a lot of drugs are so successful. They're so successful because they can either manipulate our own natural neurotransmitters that our brain makes, or they can mimic, meaning that they can copy. Like to mimic is to copy someone. And so they can mimic the neurotransmitters that our own brain makes. And so alcohol stimulates the release of endorphins. And remember the endorphin rush, like after you hit yourself, and it feels like pain. So if you ever hit yourself and you feel pain, and then afterwards it feels a little bit good, that's called an endorphin rush. And so alcohol at first stimulates endorphins. Those endorphins bind to opioid receptors. And so, these are how the receptors look like. Endorphins are being released from the neuron. And so here you have it in the endorphins in the synaptic cleft, binding to opioid receptors. And then the opioid receptors cause like a signal for the release of dopamine. And we all know what happens when dopamine is released. You feel pleasure. And so, alcohol has this effect. An alcohol molecule, the alcohol molecule itself, the ethanol, mimics a neurotransmitter called GABA. And so we learned about GABA. And let's see if you remember. So is GABA an excitatory neurotransmitter or inhibitory? So excitatory means that it'll cause your neurons to fire at a fast rate, so you get a lot of signaling. Or inhibitory means it'll cause your central nervous system to slow down, so you have less firing of the neurons and you'll be more relaxed, more slowed down. And so if alcohol enhances GABA, what do you think GABA is, excitatory or inhibitory? If you said inhibitory, you are correct. And you know that side effect that alcohol has, which is, what do you think is the side effect? Yep, if you said drowsiness, relaxed, or tired, this is the reason why. Is because alcohol mimics GABA, and GABA is something that slows down the central nervous system. So I know earlier I said that alcohol at first is like a stimulant. That's because of how it first affects you. But alcohol continues, to stay in your body for a while, so you end up having more and more effects of the central nervous system. And so one of the next things that it does is it starts to slow you down. And so that's why some people end up feeling drowsy, relaxed, tired, because the central nervous system is slowing down due to alcohol affecting the same neurons or binding to the same receptors that GABA binds to. And so it's telling the central nervous system to relax. And that relaxed effect is what people like about alcohol. It helps them like feel like, oh, I'm invincible. Like, I can do things without feeling embarrassed, things like that. So ethanol enhances GABA-mediated synaptic inhibition. And if this is prolonged, like for people who are chronic drinkers and they have been drinking for a long time, messing with the amount of GABA in your body can actually lead to mental health problems such as stress, depression, and paranoia. And so that's why this is one of the reasons why some people end up developing depression if they drink a lot. It's because of how the body has affected the GABA being produced. And ethanol also inhibits glutamate. And so glutamate is another neurotransmitter, which is excitatory, meaning that it stimulates you. And by inhibiting it, it means that, hey, glutamate, you cannot be binding to neurons right now and exciting them. You need to chill. And so alcohol not only, increases GABA, but then it stops glutamate. And so that's why you get that whole, relaxed effect. Isn't it interesting how, drugs affect your brain? It literally is like hijacking your brain cells and having them behave in a different way that they normally wouldn't, which I don't know. I just kind of find it interesting that drugs can do that. And so, not surprisingly, alcohol also affects the serotonin levels. And so, does anybody remember what serotonin is linked to? If you said mood and feelings, you are correct. And so, serotonin is associated with our feelings and our mood. People with low levels of serotonin, or studies have shown that people with low levels of serotonin tend to be depressed. They tend to be in a bad mood. They don't feel that great. And so serotonin therefore affects our mood. And so in the short term, this is for short-term drinkers, people who drink alcohol actually have an increase of serotonin. So this is pleasure. This is the feeling of pleasure, and nausea, I guess, associated with nausea. Now this is short term. And so what ends up happening is that for people who drink long term, if you keep consuming alcohol, and therefore alcohol is stimulating your brain to release serotonin, when you're not drinking alcohol, your brain will stop releasing serotonin, and this can cause problems. This can lower serotonin levels, and that may cause depression. And actually, I'll admit, when I believe when I was first started college, I was like in my early 20s. I really loved to party on the weekends. I'm not going to lie. Like I loved going out 2-3 days a week, just because I never got to when I was living at home. My parents were very strict. And so I kind of just like went out a lot. And I liked drinking on the weekends, whenever I would go out. And after a year of doing this, which is excessive, that's considered long term. I noticed I started developing depression. And so I went to go see a doctor, and they actually had to put me on SSRIs. And that was because of the alcohol. And so you do have to be very careful. If you think it's innocent, even if you think like, oh, I'm going to just have some drinks when I, go out on the weekends, it can add up. At least it happened to me. We're all different. I'm not going to say what happened to me will happen to you. But yeah, I actually had to be put on SSRIs, and that helped me realize, and that made me learn how serotonin is affected through long-term use of alcohol. And this was somewhat new for me, but alcohol also affects the cannabinoid receptors. Basically, what it does is that it stimulates the cannabinoid neurotransmitter anandamide, so that means that more anandamide is produced. And ethanol and then cannabinoids activate the same reward system, and so this helps a person feel that reward whenever they drink, and so it kind of enhances that feeling of reward. And so in the long term, because you're overstimulating the cannabinoid receptors with anandamide, in the long term, it tends to decrease the cannabinoid receptors. This is called like downregulation. And that's because it's just being so overly stimulated. And then this affects the nucleus accumbens. Remember, we said that the nucleus accumbens and the ventral tegmental are super crucial to the reward system pathway, and also very crucial in the addiction pathway. And so this affects the nucleus accumbens, which then increases the cravings for alcohol. So now you have this wanting of more and more and more, and you want to drink more and more and more to compensate for the downregulation of the endocannabinoid receptors. All right, so let's talk about your brain on alcohol. So it affects your forebrain, your midbrain, your brainstem. And remember, in one of my earlier lectures, I don't have it on here, but you get this side effect called ataxia, which affects your cerebellum, which is in the back of your brain. And that's the reason why a person loses coordination, like while they're drinking. It's because it kind of like, it affects pretty much, a lot of sections of your brain. And it's not surprising. That's because the molecule, it can easily diffuse in the neurons. And so, they don't have a hard time affecting different areas of the brain. And so, first, alcohol affects the forebrain, which assaults the motor coordination and decision making. And so people can make poor decisions, they don't walk well, etc. And then alcohol knocks out the midbrain, and you lose control over emotions and increase chances of blackout. Have you ever cried? Well, I don't know what age you guys are. Maybe some of you are under 21. Maybe some of you are over 21. But, I have plenty of friends, including myself, in which alcohol has made us cry. Like, it's just one of those side effects. And then finally, alcohol batters the brainstem, and it affects heart rate, body temperature, appetite, and consciousness, and potentially fatal condition if you drink too much, and there is such thing as over-consuming. And so your brain develops the same way the rest of your body does over time. It continues to develop to about the age of 21. This is one of the reasons why our drinking age is 21. And so you don't want to be consuming alcohol when you're still in the process of development, because that can actually affect the way that your neurons communicate. So it can be very harmful, to the brain if a person drinks very young, because these are the stages of development. And so that's why the legal age is 21. And so here is basically a brain scan. A brain scan basically tells you how much activity is going on in the brain. And so this is of a sober person, and so you can see that they are stimulated in many areas of the brain. And then when they are intoxicated, the brain is just basically not communicating very well, and so it's not too stimulated. All right, let's talk about the psychological effects. And so these are the long-term effects on the brain. And so this is of a person who is a chronic drinker. And so if they tend to drink too much in adolescence, meaning that you are in your teens, you're too young, you're under 21, there is a chance of higher rates of depressive symptoms, which is not surprising because you are messing with the serotonin levels, and childhood conduct disorders. There's a greater volume of reduction in the frontal, lateral, and temporal brain. I don't understand this males only. This came from the textbook, but maybe because most studies were shown in males, or maybe they did, studies in males and females and showed that this is just something that happens to males more. But I mean, reducing the volume of the brain is dangerous because that just means there's less neurons, less connections, and so that can heavily affect your everyday life. And there's also less growth in the corpus callosum and pons white matter growth. And so the corpus callosum is what connects the left hemisphere to the right hemisphere. And so that means that there's less communication going on between both hemispheres. And so it's very detrimental, to adolescence. And so even I think 21 is actually too young. Personally, I still think that. Just because at 21, people tend to be impulsive. I still think that at 21, we make poor decisions. I would want to heighten the age. I would think like maybe 23 is an okay age to start, but who am I to say what is the appropriate drinking age. But anyway, now if a person has a long-term use of alcohol in midlife, meaning that they are older, so this is like 21 and over, there's a double risk of the latter life long-term cognitive impairment with monthly binge drinking and more rapid cognitive decline. And so this just means that a person like they are more susceptible to overly drink, meaning that they will probably drink like 10 beers, in a few hours or something like that. And if you drink it at midlife, that also means that a person, so as we age, our brain or our cognition tends to decline. It's just a natural part of aging, but alcohol can actually accelerate that. And so you can kind of like age faster, basically, because your brain is just not working as efficiently. And so it does affect people differently when they are adults than when they are adolescents. Now, the side effects and toxicity of alcohol users, now these are chronic alcohol users, and so these are people who drink abusively, are in risk of reversible drug-induced dementia. So dementia is when you're forgetful. You don't remember things. Liver damage, which is not surprising because your liver is just producing these enzymes to break down alcohol. And if you just abuse it, if the liver just produces so much of this enzyme, after a while it'll be saturated and it'll stop producing it. So liver damage is not surprising. Digestive system damage, that's not surprising either because of how easily alcohol diffuses through the tissues. The destruction of the nerve cells, not surprising either, just because of how easily alcohol can diffuse into the nerve cells. And an increased risk of cancer, which means that, and cancer is caused by there's no one way that cancer is caused, but cancer is known to be like a disruption of the of DNA when it's multiplying. This is just put in simple terms. And so cells kind of go haywire, and cells don't necessarily listen to the other cells in the same environment. And so they kind of lose their cues on how to be a proper cell. And this usually happens during DNA synthesis. But anyway, point being that alcohol can increase risk because it just messes with the cellular machinery. That's an easier way to put it. So alcohol can easily mess with the cellular machinery. All right, let's talk about the psychological effects of alcohol, which is linked to alcohol intoxication and crime. So dose-related increase in aggressiveness, responsiveness in both males and females. So this just means that aggressiveness has increased in people who are pretty much alcohol abusers. Alcohol has been implicated in over 50% of homicides and assaults, meaning that murders and fights and stuff like that have been the cause of basically alcohol abuse. Over 40% of violent offenders in prison were drinking at the time of offense. And alcohol has also been linked to an inappropriate sense of mastery, control, or power, meaning that because of these behaviors, because of how they feel control or power, they're not thinking straight, and so they tend to have more poor decisions, poor decision making. And alcohol myopia has also been developed by many drinkers, meaning that the person at the time that they're drinking behave in one way. So for example, you can be the life of the party, or that person can be loud and funny, but then after they're done drinking, they're not that person whatsoever. They could become distant and quiet or whatever. And so, so it just basically changes a person's behavior, but it is heavily linked to aggressiveness. And so some people, have had alcoholic parents and have, been victims of abuse, unfortunately. Others have been married to an alcoholic and have experienced, their abusiveness, but not necessarily all alcoholics, are aggressive. I grew up with a parent, my father. He was an alcoholic for a short period of time. I'd say like about 5 years. Luckily, he was not aggressive. He was actually really nice. He'd give me money all the time. He was just a really kind person, so I got lucky. But I didn't like that he was an alcoholic because he would make poor decisions. And it scared me. I was always scared for him. And so, we all have different situations. I also have a different story. I'd say about 4 years ago, I had a good friend, which was very successful. He was what was he? He was like not like a computer scientist, but he did the code. He was involved in coding, and he made really good money, super successful. And the more we started hanging out, the more I realized he had a problem because I would notice a personality switch. And one day, he admitted to me that he was going through rehab, which is fine, no judgment here. And I guess he wasn't, I guess he needed more time in rehab, or he wasn't supposed to be hanging out with other people. And I didn't know that at the time because I didn't understand how rehab worked. And so when he would hang out with me, I guess he would bring alcohol with him, and I didn't know. And so he would sneak and drink it. He would drink it behind my back. And then later on, I finally figured out, like, oh, this is why he had these personality changes. Like, he would be more mean out of nowhere. And then once I caught him drinking hand sanitizer, and so that's how I knew it was a problem. And that day that I caught him drinking that, he was just feeling really sick because people who are severe alcohol abusers, they need to actually continue drinking. If you're not in treatment, if you're not in some type of treatment in which somebody's watching over you, if you stop drinking, you can actually develop withdrawals, like really bad withdrawals, which can lead to seizures and whatnot. And so that made me decide, like when I saw him, drinking the hand sanitizer, I figured it was a real problem. And he seemed like he was really sick. He just seemed really out of it. So I ended up taking him to the hospital and he got treated. And then I called the rehab center. And so I found out which rehab center he was in because he wouldn't tell me, but I found it. And I had them take him back. And so, yeah, it was really scary, actually. I felt really bad for him. And then I even went, like, to be supportive. I went to some of his rehab, like, support groups, which was cool. It helped me in other personal areas of my life. I liked it. And, I kind of just showed up to his group sessions, like, I'd say for, like, a good month, like, once a week. And it was interesting, to see what people have gone through and, the reasons why they do what they do and whatnot. But anyway, that's a side story. I'll move on. Let's talk about the consumption of alcohol. And so an average person can metabolize around 10 to 14 milliliters of alcohol. Well, this is of 100% alcohol per hour. And this is independent of the blood level of alcohol. So this is independent of the BAC. And so that means that a person can consume 4 to 5 ounces of wine, or 12 ounces of 5% beer, or 1 to 1.5 ounces of 80% proof whiskey per hour would be fine, and that would keep the blood alcohol levels in a person fairly constant. So they would be able to metabolize that, and it wouldn't necessarily be too toxic. And so let's talk about blood alcohol content, or concentration, really, which is BAC. And so these content levels are normally taken when a person has been, let's say, pulled over from suspected drinking and driving. And so these kind of tests can be administered. And so a blood alcohol concentration, let's say, of 0.1 means that there is 0.1 grams, of alcohol for every 100 milliliters of blood. And so basically what this means is that this is how much alcohol is concentrated in the blood. Okay, so this is just a measure. And so does anybody know what measure is considered illegal in order for an individual to get a DUI? So if you said 0.08, then you are correct. And so these are some of the charts of the blood alcohol concentrations. So if you are below 0.08, that means, let's say if you're at 0.02, 0.03, you might feel mildly relaxed, sociable, talkative, and flushed. If you drink a little bit more, you may begin to have some impairment. Your ability to drive safely begins to be limited. And so, even this is not recommended to drive. And 0.6 to 0.7, judgment and driving somewhat impaired, pupils dilated, slightly uncoordinated thickness of speech, or it should be like slurred speech. And 0.08 is judgment and driving impaired, so you are completely impaired at this point. You should not be driving whatsoever. The level of intoxication in most states is at this point. And a person also has unstable, exaggerated moods, and so they're just not all there. And then anything higher than that is like loss of inhibition, and even higher possible vomiting, drowsiness, loss of critical judgment. Even higher than that is drunk, staggering, irrational behavior, no coordination. 0.16 and 0.30 is very drunk, may lose consciousness, so this is when a person blacks out. And if you have a blood alcohol concentration of 0.3 or more, that can actually lead to comatose death, and so it can be very fatal. Under the age of 21, if a person is caught drinking and they're driving, then the legal limit is 0.01, so even before this, and so you can get a DUI just based on that. And of course, the blood alcohol concentration levels will be different for males and females because of the water content. So for females, they can feel the effects and they can have a blood alcohol concentration that is much higher just by having one drink. And so one drink is, 0.02, 0.03, and that lasts for about 1.5 hours just because it takes that long for your body to metabolize it, your liver. And 2 drinks is from 0.04 to 0.06. 3 is 0.05 and 0.09, and so this is the illegal limit. This is the DUI limit, and it takes 4 to 5 hours for the body to metabolize that. And then 4 drinks and so on is just going above the illegal limit. All right, so let's talk about the synergistic effects of alcohol, which is basically what occurs when different drugs in the body are taken at the same time with alcohol to enhance each other's effects. And so this is 2 or more drugs that have similar actions. Like, for example, if you take a depressant with a depressant, because alcohol is considered a depressant, and overall it is considered a depressant, even though it stimulates you when you first drink it, but it is a depressant because of how it slows down the central nervous system. And so if you take alcohol with, let's say, a barbiturate or a benzodiazepine, or some type of opioid, these drugs may severely depress the central nervous system, meaning that it can severely slow it down, so much so that it can lead to death. It can put a person into a coma, and they won't wake up. And a person can also drink a stimulant and a depressant at the same time, so you have an upper and a downer. And an example is cocaine with alcohol, or cocaine with barbiturates and alcohol. And so this may build up lethal levels of the drug because of metabolic issues. And so stimulants impede the liver's processing of barbiturates and alcohol. So having all of these drugs in the system mean that the liver, is going to be impaired in which one it should metabolize, and so it can enhance the effect of one drug. And so, for example, alcohol plus aspirin can cause the risk of a person bleeding, like stomach bleeding, and so that's why they say it's not good to, if you take an aspirin or like even Motrin, like Motrin, ibuprofen, all of those things, they say you can't have that. Let's say if you have a headache and you take it, they say you should not be drinking because of this risk. And alcohol and a sedative can lead to coma and death. Remember, this is a downer plus a downer. And alcohol plus cocaine can increase high blood pressure and cause irregular heartbeat. And alcohol plus barbiturates can cause hypothermia, respiratory depression, lethargy. loss of coordination, and low blood pressure. And so just having this mix is really bad for a person. All right, so let's talk about alcohol tolerance and dependence. And so tolerance and dependence are people who regularly ingest alcohol. They can develop 3 types of tolerance, although I'm only talking about 2 types here. So correction, we're talking about 2 types of tolerance. The first one is metabolic tolerance. So this means that the liver starts metabolizing alcohol more effectively, or not more effectively, it just increases the amount of enzyme, which means that they can tolerate more alcohol. And so if you have more enzyme in your body breaking down the alcohol, what do you think that will lead to? So again, you have more enzyme, your liver starts making more enzyme to break down the alcohol. So what does that mean for a person? What that means is that they have to drink more alcohol, even more alcohol, just to have the same effect, because the liver has been getting better at breaking it down, and which is also a reason why people can develop liver, disease, because the liver is just so overactive. Also, it can affect the tissues. So tissue or functional tolerance means that neurons adapt to the presence of the drug, and blood alcohol levels can be double the amount of those of non-tolerant drinkers. And so let's say, for example, a chronic drinker, they can, let's say, drink 3 beers, and a person who is not an alcohol abuser, let's say they're occasional, they'll drink 1 beer, and that person who drinks 1 beer will have the same type of effect as a person who drinks 3, that basically has an alcohol problem. That's because their neurons have adapted, to this, and so they're just more effective at getting rid of it. And so if your body becomes good at getting rid of the alcohol, because of course it wants to do that, it feels toxic, then that person will just need to drink more. All right, so this is withdrawal. So this is what happens to people who, are chronic abusers of alcohol. And so withdrawal can develop in several hours. And so withdrawal means that a person stops taking the drug. And so this is for a person who stops drinking. And this is, again, for a chronic abuser. And so detox often involves blocking seizures. And so the reason why I have that on the slide is because people who withdraw from alcohol, let's say they cut it cold turkey, they just completely, this is a person who drinks a lot, by the way. So a person who drinks a lot, and they have been doing this for years, completely stops cold turkey, they can actually develop seizures. And so one of the treatments for that is to give them a benzodiazepine. And so a benzodiazepine is something that prevents a person, it's an anticonvulsant, so it prevents a person from breaking down into seizures. And there's also the kindling model of withdrawal, which means that the repeated withdrawal of alcohol. So let's say a person stops drinking, and let's say they withdraw, and they do this more than once, and their body goes into a seizure. What happens is that you can increase the amount of seizures and the likelihood of getting seizures if a person keeps doing that, if they keep withdrawing out of nowhere, just because let's say they're trying to quit and they don't get treatment. So if they keep doing this to their body, and they keep doing this and doing this, studies have shown that it can actually increase the severity and the likelihood that a person will develop a seizure. And then a person also can develop something called delirium tremens, which is shaking. And so a person, when they stop drinking, when they withdraw, they can start shaking, they can start hallucinating, they'll feel really agitated, and they'll have sleep disorders and confusion. And so alcohol withdrawal can actually be pretty brutal. It can be very hard on the system. So now let's talk about treatments for alcohol abuse. And so one of the treatments is called disulfiram. And so under normal metabolism, alcohol is broken down in the liver by the enzyme alcohol dehydrogenase. So we talked about that earlier, that alcohol dehydrogenase is an enzyme that breaks down alcohol. And basically what disulfiram does is it blocks the reaction of the intermediate stage of acetaldehyde dehydrogenase. This is the second enzyme. And so by blocking that, and so if you block the breakdown of alcohol, okay, and this is used for treatment. So if you block the breakdown of alcohol with disulfiram, which basically blocks the second one, it blocks acetaldehyde dehydrogenase. This is the second enzyme. That means that you'll have more acetate hanging out in your body, and you'll have more acetaldehyde hanging out in your body, and that could make a person feel sick. And so that can make a person feel like they want to throw up. They can have horrible hangovers, and it can make him dehydrated. It can make him flush. And so, yeah, this is actually used as a treatment so that when a person drinks, they feel horrible. And actually, my friend was taking this. He had later revealed to me, and this is a friend that, I told you was in rehab. All right, moving on. And so, this is the medication here. And so 5 to 10 minutes after alcohol intake, the patient may experience the effects of a severe hangover for a period of up to 30 minutes to several hours. And so, again, this just makes a person feel like alcohol tastes gross to them. And again, for some individuals in which we genetically are predisposed to making a poor amount of this enzyme, I think I'm one of those. We naturally kind of don't want to drink just because we have those horrible side effects. I do get hangovers, and I do get severe dehydration, and I hate it. Anyway, naltrexone is another one. We've talked about this before, and really what naltrexone does is it blocks opioid receptors. And if you are blocking opioid receptors, that means that you are blocking the release of dopamine, like too much dopamine, because the dopamine is, linked to the cravings of the alcohol. And so by blocking the opioid receptors, you're reducing the dopamine, which then reduces the cravings. And so interestingly, naltrexone is not just used for the treatment of drug abuse. I've actually seen this online, that it's also used for people who want to lose weight, which makes sense because, the addiction to wanting to eat all the time. And so, yeah, I've actually seen it as a treatment for weight loss, which I thought was interesting. I mean, I don't know if it works or how that works, or I'm pretty sure you have to, be seen by a doctor, and they have to decide whether they want to give you naltrexone. But yeah, I definitely have seen it being used in combination with something else, maybe phentermine or something, for weight loss. Just really quick, just wanted to touch up on this whole cup of wine a day for the heart. And so some research suggests that drinking an occasional glass of red wine is good for you. And so this literally means just a glass, not 2, not 3, not 4, because when you start, increasing it, it's no longer just a glass. Because now your liver, has to metabolize all of this alcohol, and then it takes forever for your body to get rid of it. So anyway, drinking 1 glass of wine a day can be good for you, according to some research. I'm not at all saying that that's true. I'm just saying according to what I've read online. That's because wine, and this is wine specifically, and actually red wine, because red wine has some antioxidants and may promote longevity and can help protect against heart disease and harmful inflammation, among other benefits. And it also just reduces blood pressure. And so if you're reducing your blood pressure, if you're more relaxed, that means your heart is not overworking. And so, yeah, this has been shown as a recommendation. So I didn't want to completely say that alcohol is just horrible. I don't have any judgment on it. And if you do drink, just, drink in moderation, be safe. And if you are at a place in which you need a ride home, there's always Uber, or always call a friend. Just be safe in what you do.